Remember that ratings histogram code that we ran for your first Spark program? Well, let's take a closer look at that and figure out what's actually going on under the hood with it. All right, so understanding concepts from PowerPoint slides is all well and good, but nothing beats looking at some real examples. So let's go back to that ratings histogram example that we started off with in this course and break it down and understand exactly what it's doing under the hood and how it's using RDDs to actually get the results for the ratings histogram data. So the first couple of lines is just boilerplate stuff. One thing you'll see in every Python Spark script is the import statement to import Spark conf and Spark context from the PySpark library that Spark includes. And you will at a minimum need those two objects. The Spark context we talked about earlier, it's sort of the fundamental starting point that the Spark framework gives you to create RDDs from. And you can't create a Spark context without a Spark conf, which allows you to configure the Spark context and tell it things like, do I want to run just on one computer, or do you want to run it on a cluster, and if so, in what way? And the other bit of housekeeping from the beginning of our script was importing the collections package from Python, and that's just because we want to sort the final results when we're done. That's just standard Python stuff. Next, we actually create our Spark context, and this is going to look very similar in every Spark script that we write in Python. So let's look at what's going on here. We have the Spark conf object that we imported earlier, and we're telling it to set its master node as the local machine. So basically it says we're going to be running on a local box only, not on a cluster, just on this one system. And there are extensions to local that tell you to actually split it up among multiple CPU cores that you might have on your machine, but this is a very simple example, so we're just going to run it in a single thread on a single process, and that's what local means. So we're not really doing any sort of distribution of the data in this case. It's just sort of running on one process to keep it simple for now and kind of get the concepts across. Later on, we'll run more complicated jobs that actually use every core of your computer, and ultimately we'll run a job on a real cluster using Elastic MapReduce. Finally, we need to set the app name as part of this call. We're going to call this app ratings histogram, and that's just so if you actually look in the Spark web UI to actually see what's going on while it's running, you'll be able to look up the job by its name there and understand and identify it. Now, this job runs too quickly for you to even see it in the UI, so we're not going to worry about that, but it is good practice to give every app a name here. And finally, using that Spark configuration object, we create our Spark context object and assign that to something called SC, and by convention we will always call that SC for Spark context. So now we're going to load up our data file, and if you remember from the previous lecture, a very common way of creating an RDD is through the sc.textfile method. So this is actually going to go out to our local file system and go to the ML100K 100,000 rating dataset from Movie Lens and load up the data file that includes all of the movie ratings data. Now, if you were to open up the u.data file in some sort of a text editor, it would look something like this, only with 100,000 lines. And what TextFile does is it breaks up that input file line by line so that every line of text corresponds to one value in your RDD. So the first value of the lines RDD is going to be this entire line of text, and the second line will be this line of text, and the third value will be this line of text, and so on and so forth. So if this were my entire u.data file, my RDD would consist of 5 values where each value is a string that represents a line of text. Now later on we'll actually break that up into what that string means. And that's what our mapper function does. So remember, the lambda sequence allows us to have a shorthand of passing some sort of function that we want to pass into our map. So lines.map lambda x, where x gets passed into split, and we extract the 2 number field. Now remember, in programming we always start counting with 0, so what that's going to do in every line is take the line of input, it's going to split it based on white space individual fields. So running split on each line is going to result in a list of values of 196, 242, 3, and this big number. And what these numbers represent are the user ID, the movie ID, the rating value, and a timestamp. So the way to interpret the u.data file is user ID 196, watched movie 242, gave it a rating of 3 out of 5, And he did this, or she did this at this particular timestamp, and that can be translated, into an actual human-readable time. That's epoch seconds, if you're curious. And the second field, if we count from 0, 0, 1, 2, is actually the rating itself. So what's this map function actually doing? Again, it's splitting up each line into its individual fields based on white space, and then it's taking field number 2, which is 0, 1, 2, the actual rating value. So for every line, it sucks out the rating value and puts that into a new RDD that we're calling ratings. So make sure you understand what's going on here. This is a very fundamental thing to understanding Spark. And if you need to hit pause and stare at this some more, do what you got to do, because it's very important that you get this concept. If you don't, you're going to have a hard time going forward. So understand that this little one line of code here is going to take every individual input line from our lines RDD, which contains the raw input data, split it up into fields, and we just happen to know that this means that user ID watched this movie ID, gave it this rating at this time, extract the rating, which is field 2, and put that into a new RDD called ratings. So we start with this, and after this map operation, the ratings RDD gets populated with these values. So our new RDD called ratings will contain 3, 3, 1, 2, 1, because those are the ratings values extracted from the source data. It's also very important to remember that the map function and all the action functions don't transform the RDD in place, so your lines RDD remains untouched. What it's doing is creating a new RDD called ratings, and you need to remember to assign the result of that transformation to a new RDD, or else it will just go nowhere. Very common mistake there. You can't just call lines.map and expect it to change everything in your lines RDD. You need to assign that result to a new RDD. In this case, we called it ratings. So if you got that, great, let's move forward. If not, again, hit pause, rewind, do what you got to do to understand this slide. Very, very important concept. All right, finally, we're going to perform an action on our RDD. So we've transformed the RDD into the form that we want. We've taken our raw input data and created an RDD that contains nothing but ratings as its values. So at this point, we call our ratings RDD includes just the rating values in our example 3, 3, 1, 2, 1. And now we're going to call an action method on that RDD, count by value. And this is a very easy way to cheat and very quickly create something like a histogram. What it does is it counts up how many times each unique value in the RDD occurs. So in this particular example, we know that the rating 3 occurs twice, the rating 1 occurs twice, and the rating 2 only occurs once. And that's the output we'll get. We'll get these pair values, these tuples, if you will, of rating and then the number of times it occurred. 3 occurred 2 times, rating 1 occurred twice, and rating 2 occurred once. And that's what will end up in our result object. And all it's left to do at this point is to print that out. Now this is an action, so it's actually returning, just a plain old Python object at this point. That's no longer an RDD, so we can do what we want to do in order to sort those results, which is the final thing we do. And this is all just straight up Python code. There's nothing Sparkish about it. All it's doing is using the collections package from Python to create an ordered dictionary that sorts those results based on the key, which is the actual rating itself. And then we're going to iterate through every key value pair of those results and print them out one at a time. So the output of this bit of code is going to be rating 1 occurred twice, rating 2 occurred once, and rating 3 occurred twice. That's all that's going on here. So we're taking those original key value pairs that were returned by count by value, and we are sorting them just using this boilerplate Python code. And I realize you may be new to Python, but if you look at this, it's pretty self-explanatory what it's doing. As we go into more exercises in the future, you can use a lot of these examples that we're going to give you to actually create what you need and piece together the pieces that you need to actually construct your own program. So kind of keep these snippets of code in your toolbox for future use. It's just that easy. So, we only had a handful of lines of code. Let's actually look at it as a whole again and take a look at that program all in one piece within Canopy and run it one more time just to reiterate what's going on. So now that we have a better idea of what's actually going on here, let's take another look at that ratings counter script as a whole. Go back to your Spark course. directory there and open it back up in Canopy. And here we are. So again, here it is all together. Looks a little bit neater in here. So once again, let's review what's going on here. We're importing from PySpark the SparkConf and Spark context objects, and you're going to have that at the beginning of pretty much every Spark Python script that we write. We're also going to be using the collections object to sort our results, so we're going to import that now. Next, we create the Spark context object using a SparkConf that we create with a name of ratings histogram, and we're going to run it locally just on one process for now. Now, the magic of Spark starts happening here. We create an RDD called lines by calling sc.textfile, given an absolute path to our data file for the movie lens dataset. And again, that data file contains 100,000 rows, 100,000 lines, and at this point, every one of those lines will be a value in this lines RDD. Now, we're going to apply a map to that lines RDD and pass in a lambda function that splits out that line, breaking it up by white space and taking field number 2 out of each line. And again, each line of the u.data file represents a user ID, a movie ID, a rating, and a timestamp. So field number 2, given that we start counting from 0, ends up being the rating value from each line. So what this line does is it takes our lines RDD that contains raw lines of text from our raw input data and creates a new RDD called ratings, which contains only the ratings values from that input data. And now that we have our RDD transformed into the form we want, where every line, every value of the RDD is a rating value, we can call count by value to get a count of how many times each unique rating value occurs. And that gets output into a plain old Python object called results. And we can then turn around and use the collections package to sort those key value pairs of keys representing the ratings and values the count of each rating. We're going to sort those, and then we're going to iterate through each result and print them out to the screen. So just plain old Python code there, given the result generated by our ratings RDD when we called count by value on it. One more time, let's run this again just for good luck. Now that you know what's going on, it makes a little bit more sense. Spark Submit is just a tool that's part of the Spark framework that allows you to submit Python scripts to the Spark framework, and it does all the magic that needs to happen under the hood to make that actually run in a Scala environment for Spark. And we pass in the name of the script, ratingscounter.py, and off it goes. You'll see these warnings every time we run on our local machine here. You can safely ignore them, by the way. And there's our results. So once again, 34,000 4 stars, 21,000 5 stars, so on and so forth. And you can see now how that all happened. It was through the magic of RDDs. We started with one RDD that represented every line of our input data. We created a new RDD that just extracted the ratings from each line. And then on that RDD, we used count by value to produce these final counts for each rating type. And then we just did some plain old standard Python code to sort and display those results when we were done. And that's all there is to it. All right, now you've not only run your first Spark program, but you actually understand how it works, hopefully. So let's start building upon that and do more and more complicated things with Spark and kind of work our way up to some more complicated examples. So next we're going to take a look at how Spark handles key value data, and we'll go into more depth on that next.